Today's topic is data unit conversion.
In terms of names, we're starting with our most basic definitions here. What is a bit? A bit in computer science is a single piece of data, a single piece of binary data, which can be essentially a 1 or a 0. Okay, and that comes from the fact that everything in the computer is essentially coming from electronic signals. So the electronic signals are either on or they're off. There's every wire is either transmitting, is either having an electric current passing through it or it's not. And so for transmission, everything's on or it's off. And also if we're storing information, then we're storing it in memory that can either have be on or off. We're storing in tiny little bits of memory. So a bit is the most basic unit of data in computer science. We've also got a byte. We can't really do much with a bit. A bit is useful for maybe binary, storing whether a value is true or false or something else. But a much more usable size is a byte, which is 8 bits strung together. So any 8-bit string, something that looks like that, if we've got 8 bits put together, then we call that a byte. It's useful for a whole bunch of reasons. First of all, we can count, if we're considering unsigned numbers, we could have from 0 up to 255 if we're dealing with unsigned binary. That's just normal sort of counting. If we're dealing with with 2's complement, then we can have negative 128 up to 127 if we're dealing with 2's complement. Inside an 8-bit binary, we could also store a char. So any character like A or exclamation mark or anything else can be stored in a byte. There's lots of things that can be stored in 1 byte of information. That's one of the reasons 8 was chosen so well. It's a nice amount that becomes our basic thing. And it's in itself, it's a power of 2, which is useful. All right, but if we want to start going bigger, we don't have more words. We just start using scientific prefixes. Now, way back when, we know from science, we've got a nice word in science that is kilo, and a kilo prefix, generally speaking, in science means 1,000. Yep, which is great. Although when the computer scientists were dealing this and working out their systems, they sort of looked at 1,000 and said, oh, well, it's not a power of 2, and we like to only deal with powers of 2. So let's make, in computer science, let's make kilo 1,024. I'm just going to pause for 1 second. All right, sorry. You with me? Excellent. So in computer science, they decided that kilo was going to stand for 1,024 and also copy the other thing. So essentially, we've got kilo, which means times 1,000, and in computer science, it became 1,024. And we've also got mega, which was times 1,000 squared, and in computer science it was 1,024 squared. So essentially we were bastardizing the scientific definitions of these prefixes. And so giga is 1,000 to the power of 3, but in computer science it was 1,024 to the power of 3. And that's how it was in computer science for 20 or 30 years. Everyone was happy, apart from the scientists who said, well, you've changed our definition of kilo and we don't really like it. And so in 1998, it was decided by the IEC, which is an internet standards body, that it wasn't great. It's not great having the word kilo meaning one thing in science and a different thing in computer science. And so they officially announced that even in computer science, kilo is going to be 1,000 and not 1,024. And we're going to come up with new words for these ones. And so essentially this is a binary kilo, which we shorten to Kibi. And this one becomes Mebi, and this one becomes Gibi, which are short for kilo binary byte, or mega binary byte, or giga binary byte. So we've got those sorts of definitions now, which are the ones that we work with and the ones that we're using all the time. So if you see kilo, mega, giga, it means 1,000 to the relative power. If you see kibi, mebi, or gibi, it means 1,024 to the relative power. All of this has made it a little bit more confusing because certain modern computer systems like Microsoft, anything produced by Microsoft, still use the wrong system. They basically said, oh no, our systems are already built using the old naming scheme and we can't change them. So if you're on a Windows computer and you find out how big a file is and it tells you that it's 3.2 megabytes, it might say 3.2 megabytes, but it actually means 3.2 megabytes, and that causes a problem as well. Hard drive manufacturers tend to use whichever one suits their advertising purposes. So if it makes it sound like it's bigger when it's actually smaller, they'll be using mega. If they're actually talking about practicality things, they'll be using mebi and they'll be using the correct language. So you can't really trust if you buy a hard drive that's 1 terabyte, let's say you're buying a hard drive that's 500 gigabytes, you don't really know if it's actually gigabytes or if it's a gibi bytes. There's no sort of law enforcement around that sort of thing. So in terms of advertising, they can say whatever they want as long as it fits one of those definitions. All right. So with that in mind, no, I don't think they'll go to terabytes or petabytes. I don't even think they'll go to gigabytes without explaining what a gigabyte is. The main one, nearly always, in any test or exam situation, you're only really going to need to worry about kilo as the main one, occasionally mega. But I don't even think so. If they did, they'd explain it in a test question. All right, so how do you do conversions becomes the question. Let's remember that there are 8 bits in a byte. And let's remember these numbers. That means essentially anytime you're converting from one unit to another, you're only going to be multiplying by 8 if you're going from bytes to bits, or dividing by 8 if you're going from bits to bytes, or you're going to be multiplying by 1,000, or dividing by 1,000 if you're going up and down this kilo to mega to giga, or kilo to nothing, units. What I mean by that is if we are going from, say, 3.2 kilobytes to bytes, then we're just going to need to, bytes is our unit value. So you're going to be multiplying by 1,000 or dividing by 1,000, possibly repeated times if you're going multiple steps on this chain. If you're going from megabytes down to units, for example, you'll do a times the 1,000 twice. Or you might also be multiplying by 1024 or dividing by 1024 if you're going up and down this chain. Let me give you an example of that. So if we're doing 3.2 kilobytes into Kibi bits, there's a couple of things happening here. First of all, we need to change kilo into Kibi. We also need to change bytes into bits. The easiest thing nearly always is to go all the way down to bits as my basic unit. So I'm going to work out, okay, well, how many bits are there in 3.2 kilobytes? And so that's going to be 3.2 times the kilo prefix is 1,000, and then we've got to get bytes into bits, so that's times 8. So I'm going to do that on my calculator, 3.2 times 1,000 times 8, and that gives me 25,600 bits. We need to change that into Kibi bits, so I'm going to take that number there and divide it by 1024, because 1024 is our Kibi bit prefix. So divide that by 1024, and then we get an answer of type that into my calculator, divided by 1024, and that gives me an answer of 25. That's it. So there's more examples. That's essentially, I've just given a practical example of all the notes on page 11, but there are some more examples if you want to actually read through them on page 11 of your textbook, and then there's some questions for understanding on page 12 to have a crack at.